So welcome everybody. This is the 8th Angular Athens meetup, and we're super excited to host some members of the Nrwl team. If you're not familiar with Nrwl, you will be by the end of this meetup. I don't have many more introductions to make. Thank you very much, everybody, for coming here. I hope you aren't confused with our new space. We'll talk and mingle after all the talks are done, I guess. The talks are going to be, I think, Jeff Cross is going to speak first, then Victor Savkin, and then James Henry. It's really important for us to build this community. So if everybody is here for their first time or they don't know anybody, they can speak to me or they can speak to the fellow organizers, the people with the Angular Athens t-shirts, so that they can introduce them to someone and find friends here. It's very important for us. So let me introduce Jeff Cross.
Sorry, I just took a big bite of a snack bar. I'm Jeff. I'm going to talk about monorepos. Does anybody have thoughts about monorepo? Anyone not heard the term monorepo before? Who's heard it and thinks it's a bad idea? Yeah, okay, good. I think in a lot of cases it's a good idea, and I'm going to talk about some of the tenets of monorepos and some of the policies and things that work well in monorepos. But everything I'm talking about is something you can do without a monorepo. And I'm not even going to concretely define what a monorepo is, because that's half the fun of it, is being ambiguous. But I'm going to talk about things that we believe, things that we've seen work well, myself and Victor and James at Nrwl. This is a lot of what we do. So let's dive in. The main focus is how monorepos enable collaboration. Actually, give me 1 second. I'm going to make sure I have my notes here. So we want to talk about collaboration. More importantly, how our collaboration is enabled or affected by how we store and organize our code, or how we structure our code. So we work with a lot of enterprise teams, and I think actually a lot of the use cases where monorepos have a lot more impact is for larger teams, where we're developing software at scale. You want to share things, you want developers to be portable. But let's talk about just a few things that enterprises want to see. So they want UX consistency. They want the apps they're putting out to the world to feel like they're built by a single company, with a single vision, single experience. They don't want the organizational structure to be leaked in the UI. They want a dedupe effort, so they don't want everybody reinventing the wheel, inventing the same service, the same components across several projects where they could be collaborating and sharing things and all that good stuff. They want to be agile and adaptable. So they want developers to be able to go across teams with ease, not have to relearn too many things like their build setup or how things are put together. They want developers to be pretty portable and agile, all without sacrificing their autonomy. So they want to be able to make their own choices, not get tied up in bureaucracy. A good thing to want. And so those are all good things. What do they have to do with code storage and organization? Well, let's look at two extremes, and we'll define these first before we start to dive in. So we have on the one hand, we have monorepos, on the other hand, polyrepos. And let's look at what these look like in practice. So an extreme monorepo is basically a monorepo that has many applications and shared libraries in the same version control repository. There's more nuance to how you define it than that. So just like we don't believe that having code in the same repository constitutes a monorepo. We think you actually need to have tooling that understands relationships between the things in that repository. You can't just treat things like silos in the same repository and call it a monorepo. Technically true, but when talking about monorepos, that's rarely the case. And so on the other hand, in an extreme polyrepo, we have all these discrete repositories that generally map to an app or library that depend on each other and other things in different ways, instead of being organized in the same version control system. So they all have their own history, their revision history. In reality, a polyrepo in practice looks more like this, where you've got several libraries that depend on different versions of each other managed by a binary repository. So the graph is not quite as flat, it's more three-dimensional now. We've got things that are depending on different versions across a repository. And we're going to look at some of the impact and some of the costs of this, which also it has benefits to it that we can't gloss over, but there are also some costs that often get overlooked. And let's look at another spectrum of monolithic apps and modular apps. So in a monolithic, because this is something when people hear monorepo, they say, but monoliths are bad, right? We thought we learned better from this, but they actually are kind of tangential to the conversation about monorepos. You can have them in a monorepo or not in a monorepo and still have a monolithic app. And I think most people would agree that having something more modular that's got more boundaries of development and more explicit APIs and those kinds of things is a good good thing and enables happy developers. So let's look at, in the real world, taking these two spectrums and seeing where some things fall. When I'm a solo developer, I probably can go to have a monorepo with a monolith. If I'm just developing a toy app for myself or an open source thing, I'm not going to get too fancy in how I split up packages and that kind of thing. And I'm also probably not going to be very disciplined. It's going to be monolithic unless I have tools that really encourage me not to be. And then a lot of open source projects tend to split themselves among several repos as polyrepos, and the good ones tend to do a good job about being modular. But then companies like Google are on this other extreme, where Google has a single mono repo for their whole code base for all projects. They're like 99% of their projects. So every project is in this same system. It uses the same build tooling, same version control. If I touch Google Search and Gmail, if they happen to be in the repo, I'm not saying that they are, but if I did, I could have one commit that touches both those projects together. If I wanted to make a wide change in the repository, I could make a breaking change and fix everything that's broken by it at the same time. And then most enterprise apps that we see fall kind of on this part of the graph, where they're kind of monolithic and they tend to be spread across a few monorepos, but they're not full polyrepo. That they actually tend not to split shared libraries into polyrepos. We see a lot of reinventing or re-implementing of shared pieces. So I want to talk about the ways that monolithic polyrepos make collaboration difficult, and polyrepos in general make collaboration difficult. Not impossible, but difficult. And that's, again, nothing that I'm going to talk about is something that you can't do without a monorepo. Monorepo just makes it basically free, or at least much easier. So why are they common in the first place? Why do we see so many polyrepos on enterprise teams? Well, one, the isolation afforded by polyrepos gives you total autonomy. So you don't have to ask any other team for permission. If you're not sharing any dependencies between teams or collaborating on anything, you want to rewrite things your own way, you don't have to get anyone's permission. You can move kind of quickly. You may have some costs at re-implementing things, but other than that, you don't get tied up in bureaucracy, which is a good thing. They can work well if you establish good cross-team policies, consistent tooling, and if you have good conditions at your company. But the fact is that the tooling is lacking for managing this well, and ends up making life harder a lot of the time. So let's establish 3 benefits of collaboration that we want to get right, and then look at a few use cases. So we want to focus on consistency, reusability, and adaptability, the same points that we touched on earlier. So first, let's look at consistency, and we'll use a little use case from our own system. So we have a ticketing system. We provide developer support to people. If things break, they reach out to us. We help them figure it out. And since we're a hip, young startup, we have our own common design language. And the first thing every design language has is a button. In our case, it's simple. It has padding defined, text size, border, and colors. And the designers, they hand it off. They say, okay, we think we've covered it. The developers will know what to do. We can go home. But in reality, we have 2 applications that use the button. And the 2 teams just implemented it themselves and didn't quite get it right. Like the spec left some ambiguity in a couple things. So now we've got a consistency problem that our users who are using both apps, which you know, in this case, an admin and a homepage, maybe you don't have a lot of that, but in the real world, you do have users who are using different parts of your application or different parts of your organization, and they're going to see these different buttons. And it gets worse with other components, but buttons is a good place to start. So they've implemented it, they've done it in their own repositories, slight variations from the spec, and it gives us inconsistency. So why did we end up with an inconsistent button? Well, so each app lives in its own repo. The design spec was ambiguous, and the key part here is that to create a shared repo would have taken significant work. That's something that they would have to set up the build environment, the tests, the continuous integration environment. They'd have to figure out how they publish it. Do we publish it to Artifactory? Do we just tell people to depend on Git sources? And also coming up with versioning, and which ends up with having this awkward development lifecycle where you have to develop something that's cross-cutting in 2 different repositories and coordinate those commits. So in this case, with polyrepos, it's easier to do the wrong thing because it's easier just to develop something in your repository without having to coordinate with other teams to make something shared. So if we look at the same case, and if the team had a monorepo, Let's say it looks something like this folder structure. In this case, just adding a common components library is much cheaper, basically free. You've already got the CI set up for this environment. You've got apps already that can depend on it there, that can depend directly on the source. And so in this case, if I had 2 buttons in my monorepo, it would be obviously wrong that I'm doing something obviously wrong. And so the downside of this is that now you have people who are relying on the same thing. They need to collaborate, or they need to coordinate. If they want to make a change to the button, they need to agree on that change. And I think that's a good thing. So it is a little bit more work, but it's actually, you're just eating up more of that cost up front rather than having a shared library that you're updating without getting anybody's buy-in and then later importing it and figuring out that you actually changed things in a way they didn't want to. So I think this is good tension, and this is a thing that we just help teams figure out how to do well or how to collaborate better, which is a little bit less of a technical problem, more of a people problem. So that's one example of consistency. And then the next thing was reusability, so not having to implement the same thing several times. Let's look at a use case where we have 2 isolate repos. One is a homepage and one is a customer's app, like a portal that they log into. The homepage is more of the marketing site. So they're built in isolation. In this case, they both depend on different versions of Angular. You can tell I made this graphic a while ago because it's Angular 5. The apps, they can have their own dependencies. They don't share anything with other repositories, so they can choose the versions of third-party libraries, of second-party, first-party, whatever, without any issue. But it becomes a challenge when they introduce another repository that they want to share, or another library they want to share. So if we had 3 repositories, one is the common UI and the other 2 are the apps, and they're on different Angular versions, then they have a conflict here. If this one requires only 5.0.3 and the homepage requires 5.0.4, then both of those are going to get shipped. That's a problem in and of itself. You've got 2 versions of the dependency in the bundle, which means more bytes to download. But that's not really the big issue here. Like, more bytes is just kind of, okay, we wait a little bit longer for the app to parse and compile and all that. This actually will introduce runtime failures because Angular and many other libraries use instance of checks. And if you've got 2 Angulars in the bundle that are talking to each other, they're going to fail some of those checks and the app is not going to work correctly. And also you want to do proper integration testing when developing this components library, that you want to test against all the Angular versions that it could be deployed with so you can make sure it's compatible. In this case, you could actually do something to manage that, but it's difficult. So in this case, why are they incompatible? Because it's easier to do the wrong thing in poly repos. This brings up a policy that companies like Google have implemented. Like, most people with massive monorepos or any kind of monorepo have this policy, and Victor will show NX and how we kind of naturally have this policy. But they enforce a single version policy across all projects. So this basically means, like, any third-party dependency, or naturally our first-party code, since it's in the same repo and we're doing trunk-based development, everything is going to only have one version. And this has some benefits. It's got challenges, certainly, but it ensures that your libraries are compatible with each other, your applications, your projects are all compatible because they're all at the same revision all the time. As new revisions are added, everything is a single version. In the poly repos, you can implement, like, I know teams who have poly repos with things spread out, and they implement a single version policy, but they have to have tooling and processes that do this, and it's not exactly aligned. Like, they don't have a single revision of any project that they can point to and say, okay, everything at this revision, we've tested all the projects together, we could deploy everything and it all works together. It's a lot more complicated. But in monorepos, you naturally have one instance of each library in the monorepo because of, you just have a single file tree. And assuming you're doing trunk-based development and sticking with that and avoiding branching, you stick with it. So if we did it in a polyrepo or a monorepo, we get this benefit that we have everyone on the same version of Angular all the time. We guarantee that as far as that goes, the app is not going to break. The dependency versions are guaranteed to be consistent at runtime. The unit tests for the common UI are going to test the right version of Angular that it'll actually be used with in real applications. And it eliminates that surprising runtime behavior. So that's a note on reusability. Now let's look at adaptability. And this is something more along how developers work across projects. Let's look at a use case where we have a bug to fix in an application. So a user has said something's broken in the home page. The developers figured out it was in the common UI library. They found a commit from Victor Savkin that broke things because he didn't add tests. Just pretty much how things go at Nrwl. Victor just pushes to master whenever he pleases. So they have this. They found this bug. They figured out where it started, and they exist in separate Git repositories, so polyrepo. And so they're also tested in separate CI environments. Each team has their artisanal, hand-picked CI environment that does its own thing. One team is using Circle, the other is using Jenkins. They don't know how anybody works. So let's look at what the process to fix this would look like. First, we figure out, we write a regression test, we submit our pull request, and then the tests pass. And we merge it into master, we tag it. And then I'm, like me on the common UI team, I go home for the weekend, I go on vacation for a few weeks, and as far as I know, everything's fine. But then Monday, when the homepage app team comes in, they see that the new version exists in the poly repo, and they say, oh, let's bump our version and let's write our own regression test to make sure it actually fixed the reported issue, and then they see that it failed. The common UI repository test can pass without verifying that the homepage app is fixed. I mean, I can try to make a reproduction of the homepage behavior in my repository, but I'm not actually testing it in the place where it occurred. And by the time the homepage team realized that it was incompatible, it's already been tagged, released, we've done the whole ceremony. I went on vacation, so you can't reach me. So now fixing the issue requires manual coordination across these repositories, which is, can be awkward. Like teams, this is again, without a monorepo, you can set up things that make it easy to work across repositories. It's just not something you get for free. So if we look at the same use case, but the homepage app and the common UI library in the same repository, and they're tested in the same CI environment, we flatten it. So I create the pull request with a regression. I create another test in the homepage app end-to-end test itself. And because I was able to do that, I can see the tests fail right away. So me as the developer ready to go on vacation, I fix the PR and update it. Test pass, I merge it, tag the whole monorepo, and then I can go on vacation. And we know as long as our tests are good that it should work. Since they're together, this is key. We spot it before it's merged. So we save ourselves lots of time and headache by never merging the problematic PR in the first place. And so if they are in the same repository, we can update it atomically, so we don't have to coordinate between the two repos to say, here's where I fixed it here, submit another PR in the homepage app that bumps it up and adds a test, and kind of know that these are the two revisions that go together, or track that in some way. It just is automatically atomic. And that gives us assurance that, that everything in the repo at this commit works together. So those are the three benefits, and that is all I'm going to touch on before I hand the mic over to my esteemed colleague, Victor Savkin, who's going to talk about NX probably. Well, that's it. And I think we're going to do Q&A after all three, right?